Hi there guys, and welcome to another online National 5 chemistry video. Today we're going to be focusing on branched alkenes, specifically how to name and draw. So by the end of the video today, hopefully you should be able to name and draw branched alkenes. Now this video does follow on from a previous video which explains what alkenes are, looks at the straight chain alkenes and compares alkenes and alkanes. So if you haven't looked at that video, then go and look at that first before you move on with this one. Okay. Right. Well, let's have a look at alkenes and see what you should know so far, having said that. So, this video is very similar to the naming branched alkanes video. I've deliberately kept it as similar as possible just so that you can see that it actually is very similar process. The one difference between the alkanes and the alkenes that you should know is that the alkenes have a carbon-to-carbon double bond. They cannot be alkenes unless they have this carbon-to-carbon double bond. Unlike the alkanes, which only have carbon-to-carbon single bonds. Now, what that means is that when it comes to naming, we can get rid of the alkene with only one carbon, because there can't be an alkene with only one carbon, because there has to have this carbon-to-carbon double bond. And that can't happen if there's only one carbon. Now, if you look at the other names that we've written down here, they look very similar to the alkanes. And in fact, you'll see this throughout this topic. No matter what homologous series we look at, the names are very similar to the alkanes. At least the beginnings are. The only difference is the ends. The beginnings, if you remember, depend on the number of carbons. So, like the alkanes, if you have something with 2 carbons, it begins with eth. 3 carbons, prop, 4 but, 5 pent, 6 hex, 7 hept, and 8 oct. The only difference is the ending. With the alkanes, that they ended in ane, so that would be ethane. But with the alkenes, it ends in ene. So we've got ethene, propene, butene, pentene, hexene, heptene, and octene. No methane, because you can't have an alkene with only one carbon. The full structural formula, very similar again. I will pick one to go over. The full structural formula for the alkenes, I will pick the simplest one, the ethene alkene. You have 2 carbons, so we write our 2 carbons in. They've got to be joined by a bond. But to make them an alkene, that bond has to be a carbon-to-carbon double bond. So we've got our double bond. Now, we've then got to add in our hydrogens, just like we did with the alkanes. We've got to bear in mind that carbon can only form 4 bonds. Now, let's have a look and see how many bonds is already on that first carbon. Well, we've got 1 there and 1 there, so it's already got 2 bonds on it, which means it can only take another 2. So if we put 1 here and 1 here, and we put hydrogens on here, that fills that carbon up. And again, over on this side, there's already 2 bonds, 3, 4, that fills that up. Now remember, the full structural formula shows not only what elements are involved, but how they're bonded together. Okay. Now, I'll go down 1 to propene, and I'll do that one for you. Propene, very similar, 3 carbons, so let's write those 3 carbons in, and let's bond them together. Now to make it, that's the alkane version. To make it the alkene, they have to have that double bond. Now, don't make the mistake of thinking that every carbon has to have a double bond. You only have to put it in once to make it an alkene. So to make it simple, let's put it there. Okay, that's now an alkene. And all we do is we fill in all the rest of the bonds with hydrogens. So with this carbon, there's only one bond attached to it, so that means that that can take another 3, and we put hydrogens on. With these two, you've already got 2 bonds on each, which means they can only, well, this one at the end has only got 2 bonds, so that can take 2, that's 3 and 4. If you have a look at the one in the middle, that's got 1 here, 2 here, and a third one here. Now what that means is that can actually only take 1 more bond. Okay, so you need to be careful with the alkenes. Make sure you count the number of bonds at either side of the carbon. Okay, otherwise you're going to put too many or too few bonds in and it won't be right. Writing the chemical formula is again very straightforward and very simple. All we need to do is we need to look at the number of carbons and the number of hydrogens, and we write that down as we normally would. So for ethene, you've got 2 carbons, so that's C2, and how many hydrogens do we have? We've got 1, 2, 3, we've got 4. For propane, we've got 3 carbons, so that's C3. And how many hydrogens do we have? Well, we've got 1, 2, 3, 4, 5, 6. Hopefully you're seeing a pattern starting to emerge just like you did with the alkanes. If you look and see what do you do to the number of carbons to get the number of hydrogens for the alkenes, if you double it, you'll get the number of hydrogens. So 2 carbons doubled is 4. So you've got 2 carbons, you end up with 4 hydrogens. 3 carbons doubled is 6 hydrogens. So you see, all you need to do is double the number of carbons to get the number of hydrogens. Turning that into a general formula, which is over here, would be hopefully nice and straightforward for you now, because you've had plenty of experience with general formula. We want to write Cn, n being whatever number of carbons, and H 2n. That means that whatever n is, double it, and that will give you the number of H's. That will give you the number of hydrogens. Okay, so whatever the value of the number of carbons is, double it, and that will give you the number of hydrogens. Writing shortened structural formula, we did look at that briefly before. Shortened structural formula is nice and straightforward. All we're doing with shortened structural formula is looking at the full structural formula, and we're making it just a little bit more condensed. So I'll take ethene as an example, write its full structural formula. Now always write the full structural formula out, I would recommend, before you do attempt a shortened structural formula. Even if a question asks for a shortened structural formula, write the full one, because it makes it easier. Now, all we do is we look at each carbon and we say, okay, we've got how many carbons and how many hydrogens are attached to that carbon. In this case, we've got 1 carbon and 2 hydrogens. We've got a double bond, so we need to show the position of that double bond. And in this one, we've got a carbon and 2 hydrogens. And that's what our shortened structural formula looks like. For propene, we'll do the same. Let's have a look at them all. The first carbon has 2 hydrogens round about it, so CH2. Then we put our double bond. That carbon has only got 1 hydrogen, CH. This carbon has 3 hydrogens, CH3. Now because that's a single bond, we don't need to show that. So we just write that next to one another. And that's what a shortened structural formula looks like. You can do that for any number of carbons. Okay, it's very straightforward. Just condense it down, don't show the bonds. Okay, so that's what you should know so far. If you don't know that, go back to the previous video and have a little look at it. Okay, what to take from this video? Hopefully, you should take away the rules for naming alkenes, branched alkenes. I always recommend that you write these down somewhere so that when you're doing the questions, you can have them on hand to look at. You should be able to name alkenes if I give you a structure, and you should be able to draw alkenes given their name. Okay, down the right hand side here, we've got the rules. So what I would like to do is take a few minutes and pause the video, write these rules down. Okay, the reason I'm asking you to do that is because when we move on, the rules will disappear, but there will be some questions for you to try, and it will be handy for you to have them. All right. So go ahead, pause the video just now, take those down. Okay. Hopefully you've done that. Now, in this first example, we're going to have a go at naming this. So, in the first rule, identify the longest chain of carbon atoms. Now that's the same as the alkanes. The only difference is that the longest chain of carbon atoms in an alkene must contain the double bond. Okay. Now what that means is that the longest chain of carbon atoms here is going to be this one, because it's got the double bond and it's the longest possible chain. It can't be these two, because there's only two carbons there, so it's got to be the longest chain. Number the carbons starting from the end closest to the double bond. So again, unlike the alkanes where we wanted to number closest to the branch, we want to, with the alkenes, number closest to the double bond. The reason for that is because the double bond has more of a say on how the alkenes behave. It's more important to the molecule, so it takes priority. So I've numbered from left to right. 1, 2, 3, 4. If I numbered from right to left, then the double bond would have a higher number, and we can't have that. It's got to have the lowest number. Start with the end closest to the double bond. Then what we need to do is identify the position of the double bond. So, first of all, our longest chain here is 4 carbons, so it's bute. Now, to identify the position of the double bond, all we need to do is we need to put something between the start and the end of the name. So it's butene. And what we'll do is we'll put the number of the carbon the double bond is attached to. So in this molecule, the double bond is between carbons 1 and 2. So we would call that but 1-ene, because the double bond starts on carbon 1. Now we need to identify the branch and what type of branch it is and where it is. So, looking at the molecule, the branch is here. It's got 1 carbon, which means it's a methyl branch. And it's on carbon 3, so it's 3-methyl but 1-ene. Okay, let's have another look at another example. Okay, this time we have to identify again the longest chain. The longest chain here containing the double bond is obviously this one. We need to number this now, and we need to number it making sure that the double bond has the lowest possible number. So if we number from left to right, that means the double bond is going to have start on carbon 1, 2, 3, 4. But if we number from right to left, it starts on carbon 2. So we need to do that. 1, 2, 3, 4, 5, 6. And that means that the name is going to be hex 2 ene. We've identified where the double bond is. We've identified that the longest chain is 6. And we've identified that it's an alkene by naming it ene at the end. Now we need to identify what type of branch it is and where it is. There's only one branch. It's got one carbon in it, so it's a methyl branch again. And it's on carbon 5. So it's 5-methyl hex 2-ene. Hopefully that doesn't come too much of a shock to you, because it's very similar to the alkanes. The only difference really is that we need to split the name to identify where the double bond is. And we need to start counting so that the double bond and not the branch has the lowest possible number. Okay, so bear that in mind with the alkenes. If you're unsure, go back and have another look at the videos. Try and work it out for yourself. And again, if you're still unsure, then please give us a shout. Here's some examples for you to try. So I want you to pause the video, then I'll quickly go over how we name them. So pause the video, have a go at them, and then I'll go over the answers. Okay, let's have a look at number 1. So number 1, we need to identify the longest chain. The longest chain here containing the double bond is this one. It's 1, 2, 3, 4, 5 carbons long. Now, if we number from left to right, 1, 2, 3, 4, 5, then the double bond is going to have the lowest possible number. It's going to be on carbon 2. It's 5 carbons, so that's hept. No, it's not, sorry. That's pent. It's on carbon 2, so that's pent 2-ene. Where's our branch and what type of branch is it? It's 1 carbon long, so it's a methyl branch. On carbon 4, that's 4-methyl pent 2-ene. Number 2, let's have a look at it. Well, the longest chain here containing the double bond is 3 carbons long, so that's prop. If we number from left to right, it's on carbon 1, so that's prop 1-ene. There's one branch again, so it's a methyl branch, on carbon 2, so it's 2-methyl prop 1-ene. And lastly, let's have a look at this one. So there's a lot of carbons here. Identifying where the double bond is, it's over this side, so longest chain is here. That's 1, 2, 3, 4, 5, 6. That's 7 carbons long. Numbering left to right again will give you the double bond on the lowest possible number. So that's going to be hept, because it's 7 carbons. The double bond's on carbon 2, hept 2-ene. The branch is on carbon 4. This time it's got 2 carbons in it, so it's an ethyl branch. And because it's on carbon 4, it's 4-ethyl hept 2-ene. Okay, hope you had got most of them right. If you didn't, then hopefully the explanations will explain where you went wrong. Have a go at these ones, and I will put the answers below in a second. I won't explain them, but this is just one for you to have a go at and see if you get them right. If you don't, then you can let me know which one it is, and then we can go over it. Okay, I'll pause the video while I do the answers and put the answers in for you, and you can check your answers after you're done. Okay guys, and there's the answers for you. If you're unsure, if you've got anything wrong, then just give us a shout. Let us know what it is that you got wrong, either through Teams or pinging an email. Hopefully you got that right. If there's any that you got wrong, maybe one or two you got wrong, hopefully you can see from the annotations where you went wrong. Go back through the video and have a little look, see if you can fix it yourself before asking for help. It's always worth doing that, because if you can solve the problem yourself, then it tends to stick in your mind a lot better than someone just telling you how to do it. Alright? Hope that was useful, guys, and I will see you next time.